Welcome back, students. This week we have a special guest, Dr. Jerry Dwyer, professor in the College of Education, will be walking us through several topics in mathematics. Don't be scared. I know it's math, but Dr. Dwyer makes it pretty easy to understand. So Dr. Dwyer will introduce you to some mathematical modeling, which will help you understand how epidemiologists do their work. Let's get to it.
Hello and welcome to this short course on the mathematics and science of COVID. My name is Jerry Dwyer. I'm a professor at Texas Tech University. I have a major interest in mathematical modeling. I'm also interested in how people learn mathematics and in the particular uses of mathematics in everyday life. This unfortunate pandemic has certainly given rise to areas where we need to understand more mathematics. There are a number of areas of mathematics that I find are particularly useful in understanding some aspects of this virus. In particular, we would hope that they help you to understand some of the news items that you hear regarding the virus. In particular, there are areas of fairly fundamental mathematics, not extremely advanced, that your understanding will help you to understand some of the news items regarding COVID. One area that's of interest is probability. What is the chance that you will get this disease? What is the idea behind basic probability? How many people will get the disease? What is your risk in relation to the general population? Issues of that nature come under the general heading of probability. Another area is the rate of growth of the number of infections. 2 people have the disease today. 8 people have it tomorrow. 16 people have it the day after. How do we predict this growth? How do we model this growth? And as the growth goes up significantly, we often have what is called exponential growth. And we will look at exponential growth as well. As the vaccine is developed, we have an issue of understanding the impact of the vaccine on the human body. In general, if a substance such as a vaccine or any kind of drug is injected into the bloodstream, there is a certain concentration within the bloodstream. And generally, over a period of time, this concentration dies out. Perhaps there is, we will say, 5% concentration the first day. Then maybe the second day, there is only 4%. But then maybe after another 3 days, it's down to 3%. And then maybe after another 10 days, it's down to 2%. In other words, it doesn't just decay away immediately. Of course, there is some critical percentage where it begins to lose any kind of effect and impact. So we have to understand rate of decay. In some ways, it's the inverse of the problem of the rate of growth. But this is looking at the rate of decay of a vaccine within an individual human body and to try and understand that issue. Now, fundamental to all of these issues, I believe, is the very basic and simple understanding of proportion and reasoning. What exactly is a fraction? What exactly is a percentage? What is the connection? Very often, news stories and etc. are often given in terms of percentages. I believe it is beneficial to the general population to understand very clearly the relationship between percentages and fractions, and by understanding that relationship, being able to manipulate fractions in a manner that you can actually understand the numbers more fully. So these are the particular issues that we would hope to address over the next few sessions. In general, these sessions will be extremely short. I will attempt to give some very basic mathematics. In general, for now, I just want you to see that understanding basic mathematics is important. It's important for general everyday life. In particular, it is important in understanding this spread and mitigation of this pandemic. And so I will stop here, and we will then look forward to our next session, where we will begin to talk about the basics of proportions.